Hello and welcome to this video presentation. My name is Paul Brett. I'm a Senior Software Support Analyst supporting the Transformation Extender product from IBM. The topic for this video is Azure Service Bus with ITX. Feel free to reach out to me on popular social media channels at Paul Brett Tech. In this practical demonstration, I shall create maps that both put and get messages from a queue hosted on Microsoft Azure Service Bus using the IBM Sterling Transformation Extender ITX Azure Service Bus adapter. I shall then create and deploy a system to the ITX Launcher hosted on Linux to run on a timed event and retrieve messages. I'm going to start this demonstration at the Azure Services console. I've logged in and I'm going to click on the Service Bus. If you can't see it in the initial list, you can always click on More Services here. Within Service Bus, I have a service bus called Test 1, which I have created. And then within Test 1, I'm going to click on Shared Access Policies and TempPolicy1, which is a policy I have created. Within the policy, I have disabled Manage because it's not required, and I've enabled Send and Listen. I'm going to copy the primary connection string to my clipboard and put it into Notepad for use in the map later. If we go back to Overview and then click on Queues, you will see that I have a queue called Test Q1, which currently has a message count of 0. So the next step is to create a map that will put a message to this queue. Here we are in the ITX 1102 Design Studio. And as you can see, I have a project called Azure SVC Bus, and within this I have a map source file called test.mms. Within this source file, I've created a map called put.msg, and currently this map has no cards. So I'm going to create an output card. I'm going to use a type tree that I've used many times before in my demonstrations, and it's called generic.mtt, and then within that there's an object called text item. It's just an infinite length text item. I'm going to change the adapter from file to Azure Service Bus. Next comes my connection command. For this, we're going to use the item that I saved into Notepad earlier, and we need to convert this string into an ITX Azure Service Bus adapter connection string. So all commands start with a dash, and the first command we need is E for endpoint. So we'll leave the E there, remove the rest of that stuff, and then the rest of this is the endpoint I need. Next is shared access key name, and if I remove all this stuff here, leaving in TempPolicy1 after a space, the next is shared access key. Next we need a queue name, which is test q1, and finally -t for the adapter trace, and I'm going to add a V to make it a verbose trace. We're going to copy that to our design studio. Next, the map needs a rule. I'm going to put in a text literal, but I'm also going to add on a timestamp. This is so that we can see the messages are different from each other. So now I'm going to save, build and run that map. The map has completed successfully, and if we go across to our test 1 queue and do a refresh, we will see that one message has arrived. Okay, let's write a map to retrieve that message. I'm going to copy this card to a new map called getMSG. It's going to be an input card and it's going to be called in1. Now this map has an input card. The connection string is still there. It's almost exactly the same. We just need to add on 2 additional items. -qty1 and -LSN0. I've just remembered I also need to add on the read method. For now I'm going to set the read method as browse. This will read the message but it will not dequeue it. I need an output card which I'm going to create now. The design of the output card is the same as the design of the input card, and we're just going to use the file adapter to write to a file output.txt. Let's grab a copy of the message and save, build, run. The map has completed successfully, and if we open miscellaneous we can open output.txt and we can see the time-stamped message that we got from the queue. If we go back to the queue, even after doing a refresh, you will see that the message count is still 1 because the read mode of browse is not destructive. It will not remove the message from the queue. Looking in the documentation, it does tell you the read modes available, receive mode I should say, and one of the receive modes is peak lock, which needs to be written as peak_lock. This is the destructive form of the get, and that's what we're going to try next. I fully expect this to fail because there is a bug in ITX 11.02 and a patch needs to be applied. But I want to show you this bug. So I'm going to make a copy of this map, call it get message and delete. In get message and delete I'm going to update the input card. I'm going to change the receive mode from browse to peak lock. If I now save, build and run this map, you will see adapter failed to get data on input. Because we've got the verbose trace on, we can open the trace file. Let's open that now, and you will see Java exception, invalid operation disposed receiver. So this is because of the bug I mentioned earlier, so we need to apply the patch. In the ITX 11.02 directory we have a jars subfolder. Within jars we have a folder that ends with M4AZSB. This is where the Azure adapter is kept. This is the jar file. And I can copy the patch from this patch subdirectory that I've created, but I can't do it while the Design Studio is open. So I'm going to close the Design Studio. I'm going to grab a copy of the patch. I have backed up the original already in backup. And I'm now going to restart the Design Studio. Now I'm going to that same map, get message and delete, and I'm going to build and run it one more time. And now the map completes successfully. The exception is gone from the trace file. The output shows the message that's been retrieved. It was the same message that we retrieved before, but the only difference now is that if we look at the queue again and refresh, the message count will go down to 0. So I've enqueued and then dequeued a message. I will now use the map to enqueue 3 messages, and those 3 messages are now on the queue. If we refresh, 3 messages on the queue, and now I will dequeue those messages one after the other, and you will see that it is a first in first out queue. First thing I'm going to do is on the output card is to change the output file from create mode to append mode so we can see each of the messages coming in. And I'm going to change the rule to add a new line onto the end of each message so that we can see them one after another in the file, each on a separate line. So if I now save, build and run this once, map completed successfully. We've got one message, run it again, map completed successfully. We've got the second one come in, and as you can see is date timestamped later than the first one that we retrieved. So they are coming in first out from the queue. Full details of how to get that patch will be included in the notes for this video. Next step is to modify the map slightly and create an integration flow designer document where we can deploy this to Linux on a timed event to retrieve messages on a schedule. Next we're going to deploy the map to Launcher to retrieve the messages. I found it's too difficult to get this working on Linux, so I'm going to deploy it to Windows. So I have my integration flow designer, I've put the map on the canvas, and I've changed the launcher settings to have a timed event currently switched on and to trigger every 10 seconds. The input all remains the same. I've turned on a unique audit log. This is going to append to the file output.txt. I created a deploy script which will generate the MSL and pop it into the ITX 1102 systems directory. I'm going to run that now. So the map is created and built and ready to go. The MSL is in place. Next, I need to show you that in the queue there is currently 6 messages. Let's just hit the refresh button there. Yep, 6 messages. Here's the directory. Currently no log files that are uniquely named, i.e. starting with MER. So let's bring up the output file, the launcher monitor, and then start the service. Okay, the service is running, the launcher monitor has kicked in, and this should show a green bar running along the screen every time a map runs. There we go, the map is running. It's run twice in the first 10 seconds. It should run again within the next 10 seconds. There we go, there it's running, and a third message has been retrieved. Over here, if we refresh this display, you can see 3 audit logs already. If we switch to my view, this refreshes. Now 4 lines have been brought in, and if we quickly refresh the queue, we'll see that there's now only 3 messages still sitting in there. That's obviously waiting to dequeue the third one. If I refresh again now, it's probably going to go down to 2. No, it appears the system has hung. The map has finally completed. So we'll refresh again, and now it's down to 2, and the map will continue to execute for another 2 times and retrieve messages. And then any further executions, it won't retrieve anything at all, but it will keep running every 10 seconds, trying to retrieve and dequeue messages. Back to our file display here, we've got more audit logs turning up. Back to our output file, and we've got more lines arriving in the output file. Looking at the execution log, the map appears to be taking longer and longer to run each time, possibly something to do with my design. So there's a quick summary of how to deploy the map via Launcher to retrieve and delete messages, albeit fraught with some issues. There we go, that map has just completed. Thank you very much for watching. I want to thank you for taking the time to watch my video presentation today. If you found the content interesting and informative, please hit that like button. Consider subscribing to my YouTube channel, as I release content such as this on a regular basis. Feel free to reach out to me on popular social media channels at Paul Brett Tech. Thank you.